We think, therefore we are. We are, therefore we do. We do, therefore we invent. And oh, we invent. Right from the beginning, we've been inventing for the basics, for the revolutionary, for the thing of beauty and wonder, to constantly recreate and reimagine the world we live in. And those inventions, they've made the world easier, richer, more fulfilling, more right for everybody. And each of them began just as a thought, a moment of, what if? Followed by a determined, why not? In that moment, an inventor is born. And the key to their success lies in the unusual idea they don't dismiss. It lies in their courage to challenge the status quo. It lies in the way they blend science, process, creativity, and hard work. It lies in their foresight that what I do today will have a lasting impact on the world. It lies in that magical moment when their idea stops being radical and becomes commonplace, difficult to live without, normal. And with that idea, they change the world into what they imagined it could be. At TCS Research, we seek out and nurture these thinkers and doers. We aspire to create those life-changing, business-changing, humanity-changing inventions. With scientists and researchers and experts from across industries and disciplines, we collaborate to make people healthier, to provide clean energy, to make the digital world safer so that from different corners of the world, more inventors can have their moment of, what if? Why not? We invent for today, for tomorrow, and for the tomorrow after that, to create the future that's ours to shape, to make an impact on everything there is and on everything yet to come.
Yeah, on behalf of TCS Research and ACM India, a warm welcome to all for today's session titled AI in the Physical World, Intelligence Beyond the Screen. We are entering an era which is not only about algorithms in the cloud or on our screens, but is becoming embodied in the physical world as robotic agents that perceive, reason, act, and collaborate with humans in the real world. To take you through this journey of next AI breakthrough, namely physical AI, with a $50 trillion market potential, I am your host, come moderator, Snehashish Banerjee from TCS Research and IIITG. Now let me take a moment to hand over the stage to Dr. R. Venkateswaran, representing ACM India. Venki is a professor of practice at GIP Pune and holds a PhD from Washington State University. Over to you, Venki.
Thank you, Snehashish. Let me quickly share my screen. Let me take a minute to walk you all through what ACM India is and what we do as part of ACM India. ACM, as many of you may know, is a worldwide organization established in 1947, and its sole focus is to advance the computing in science and as a professional activity. It has more than 100,000 members worldwide, 15,000 of which are based in India. The India unit or the chapter was set up in 2010. So in the last 15 years, we have grown to more than 320 student chapters and 30 professional chapters, of which about 40 are ACM women's chapters. This ACM Women chapter aligns with the DEI initiative of ACM and is focused on empowering women in computing. ACM India is very actively engaged in fostering industry-academia engagement through the learning and professional development activities, through initiatives like Eminent Speaker Program, which allows industry-leading experts to reach out or to travel to various chapter setups and deliver their expertise or share their expertise with the student and the chapter members. It also fosters a lot of engagement in the terms of webinars, like the one that we are having today, education webinars, as well as boot camps. There are a lot of research initiatives that ACM India supports by one, sponsoring these events, and two, helping the attendees to travel to these events by providing travel grants and so on. There are many focused conferences, like part of special interest groups in the form of CODS COMAD, which focused on data. There's ISEC, focused on education computing, and so on and so forth. There are many educational initiatives of ACM India that are geared towards the student chapters and student community in the form of summer and winter schools, the form of teaching partnership program, as well as CS Pathshala, which is a very unique initiative to inculcate computational thinking in schools. And it's been around for a while and has got a lot of positive feedback in terms of the way they engage with the schools. ACM India recognizes the contributions of the student and professionals as well through various forms of awards. These awards would not have been possible without the active support of the institutional partners of ACM India. We have 3 tiers. The platinum tier partners, Persistent, TCS Research, and Infosys are the platinum tier partners. And I'm very proud and happy to announce that TCS Research has been a partner since the inception of ACM India. And they have been sponsoring the annual ACM India Best Doctoral Dissertation Award since 2011. So almost 14 years now. So thank TCS Research for all the support. We also have gold tier partners and silver tier partners in Google, Ola, and IBM. If you're not an active member today, please do sign up. The link is given on the screen here, and the QR code also is given. So you can scan the QR code, fill out the application form, and you can become an ACM India member. I'm not going to walk you through what the benefits are. The website obviously gives you all the benefits that you can see if you become a member of ACM India. Thanks, Snehashis. I now hand it back to you. If there are any questions, I'll take it up at an appropriate moment. I'll stop sharing now.
Yeah, thanks, Venki, for a nice intro about ACM India. So now that the stage is set, we welcome the keynote speaker, Professor K. Madhava Krishna, the Raj Reddy Endowment Chair Professor at IIIT Hyderabad. He holds a PhD from IIT Kanpur and a postdoctoral fellowship at La CNRS in France. He heads the Robotic Research Center, RRC, since its inception, and RRC at IIITH is consistently ranked #1 in India and top 10 in Asia in robotics, according to CS rankings and AIRankings.org. His research focuses primarily on robotic perception and navigation for indoor, outdoor, and aerial robotics and manipulation. It's up to you, Madhav sir. You have to unmute. You need to unmute. Yes, yes. Madhav sir, you are still in mute. Yes, now it is.
Yeah, there is some delay. I end up pressing it multiple times. Yeah, thanks a lot, Snehashish, for the intro. And I must admit, like many of the panelists are much more well-versed and plugged into this talk better than me. But nonetheless, I'm here to give this talk. I hope I'll share my screen right now. You're able to see my screen, right?
Yes, yes, yes.
Okay, so here we go. So AI in the physical world is the title of the talk. And so we start off by saying there is this a lot of, a lot of buzz, we seem to be at a threshold of a new dawn in the deep tech world. And the new dawn seems to be indeed in robotics. And the idea is that we should be able to replicate the success which was seen in language transformers and vision transformers and the large language models and vision language models, the kind of success that we had seen in those kind of paradigms, we should be able to replicate and recreate in the domain of robotics. So much so that robotics is now a common household thing. Robots should be able to do learning across embodiments. They should be able to do zero-shot transfer in all kinds of domains, be it warehouse, indoors, outdoors, space, underwater. I mean, this seems to be the new holy grail, but it is still a hard problem, and which is seen by the Hans Moravec's statement made back in 1988. While I'm not repeating the statement here, I think I would like to possibly provide one insight, which is my own intuition. So the challenge in recreating transformers in the vision language action space, which is the new the new holy grail, is if you look at language transformers, you have language in and language out. If you look at vision transformers, it's kind of image in and image out. If you are looking at action transformers, you have maybe image and language coming in as the input, but your output space is going to be in quaternions, axis angles, rotation matrices, trajectories, 6-off accelerations, 6-off jerk, snap, and velocities. So there is a kind of a domain shift, which is you have to do these transformations from into the action domain. And the action domain need not be just trajectories on the occupancy map, or it's not the trajectories in the image, but it's trajectories in the 3D world and in a very different parameterization, such as quaternions. And also they bring in a lot of other constraints which are not typically seen in language transformers or vision transformers. So you have hard collision avoidance constraints. You have smoothness constraints, you have kinematic constraints, which all need to be also mastered by the transformer. And the idea seemed to be that if you provide a lot of data, the transformers will eventually end up learning this, not only the space of transformation between vision language to quaternions or axis angles, but they would also learn the constraints themselves, right? So this is the, I think the postmodern era, as I would call. And I'm also dividing this AI evolution. Of course, AI, as Mohan would agree, has been there ever since, or robotics has been there ever since AI has been there, or whichever way you want to see. And I'm kind of dividing this talk or this introduction into 4 eras: classical era, and what I would call is maybe say 1970 or 60 until 2010 or 12, and then the modern deep learning era, and then the postmodern GPT plus the generative AI era, and then the postmodern VLA era. So this division, of course, is a matter of convenience, but there is also some method to the way we are dividing. So the classical era, which was the dominant paradigm, say from 80s till 2010, had this the idea of solving the perception problem by the perception engineers and the planning problem or the action problems by the robotics folks. And the perception side was dominated by the so-called handcrafted features, SIFT, SURF, and then these features are learned through a SVM or random forest to do object detection and other kinds of learning stuff. And we also had SLAM dominantly in this time. We had, the idea was to build a 3D map by moving the agent around. And the map which is being built is then converted to an occupancy map or some other intermediate representation on which the planners operate. And most of these planners, be it the search space planners like RRT or the optimal control frameworks such as model predictive control, or the planning domain description language kind of frameworks. So they all actually generalize in the sense they can handle, by and large, any kind of input. But the challenge was that every time you go to a new domain, like suppose I have my motion planning operate in the indoor environment. Now, suppose I move it to a corridor with people, then I have to fine tune the MPC parameters. I have to change the constraint matrix. I have to change the Q matrix in the X transpose QX kind of framework. So every time I move, I have to recompute my parameters. I have to, in the dynamics world, it would mean I have to re-estimate the mass and the inertia matrix and things like that. So this was the challenge. While the technique itself was robust in the sense the controller or the planner can seamlessly move across domains, but then you need to fine tune. And then that poses the question like, so can I, instead of fine tuning every time, can I learn some of these parameters? So for example, can I use an RL framework to learn the inertia parameters for my manipulator? Can I use a neural network to initialize my MPC with trajectories, or initialize my controller with the action space, and then you let the controller or the take off from there, so that I reduce the search space of my optimal control. And then, so this is the way I think one can think of learning entering into the robotics arena. And also, of course, because the traditional occupancy map is pretty bland in the representation. It does not take objects. It does not take semantic inputs. So as the perception side got enhanced with all these object detection and semantic segmentation frameworks, the navigation side also latched onto this, and we were able to embed these into the mapping frameworks, and the planner was also able to handle this. For example, if I'm going to enter a narrow door, then automatically my MPC would readjust its parameter or readjust its thresholds, upper bounds, lower bounds, according to the scene, which I'm able to understand through my perception side. But I think the challenge in this era was, once again, you need a lot of data to generalize across distributions, and data was sparse or scarce, and so that was perhaps limiting this what I call as the modern era. The postmodern era seemed to have solved the data side of things, because the generative AI frameworks, stable diffusion, and other such frameworks can generate a lot of images, can generate even the world models. And they can make use of these environments like Unity, ACM, which can do industrial scale data generation. Right? And so this leads to this generative AI revolution, so as to speak. And simultaneously, one of the problems which was there in the classical style of doing things is I have to, suppose I have an end effector, then if I have to ask the end effector to move to a particular location, I have to either give the joint angles or the precise XYZ coordinates of the end effector, or maybe give the quaternions or the axis angles, which is very difficult for a human to interact with the robots by giving the goal location in terms of actual geometry. The human had to kind of speak in the language which the robot could understand. But in the postmodern era, with language models and language transformers, so this problem is now kind of resolved. Like, one can now interact with the robot like as though the robot is like a human. So you can say, put the apple in the bowl, or can you move on to the left lane and park behind, or follow the truck on the left lane, which was not the way the perceptual space or the input space was made possible in the previous era, so as to speak. So the postmodern GPT or the generative AI era had both these advantages: language as an effective interface to robots, and the generative AI is able to solve the data generation problem, and it also solves in a way the planning problem, because you can use diffusion or flow matching to learn conditional distributions, or learn the action distributions conditioned on the input space. And so this gives you just not one trajectory to optimize or not one initialization to your optimal controller, but you can have a batch initialization. So you can have a batch of trajectories, it's like giving you a batch of local minima problems to solve for the controller rather than one single local minima problem. And this was also a new paradigm shift which has come in the generative AI space. But perhaps still you can say that the perception space and the action space are still slightly decoupled, and the holy grail seems to be the vision language action transformer propelled through the historic breakthrough of RT2 and RT2's deployment in July 2023. However, the RT2 model is not available for public use, and OpenVLA also claims to do the same thing, but it lacked the promised performance. However, with deficient policy and Pi 0, we see that fine-tuning is possible, and VLA is trained over large corpuses of vision and language data and learning actions for vision language tokens. You can fine-tune across embodiments. One can fine-tune even if 1 degree of freedom of the arm is less. So like the fine-tuning is now possible, at least with Pi 0. But I think the VLA still cannot handle hard constraints like, so suppose I have to move my arm and reach out to my mobile phone across this laptop. And this hard collision constraints or hard kinematic constraints, I think, are still a challenge to this VLA, at least as of today. So we have also taken a plunge into the space, and I will quickly, in the time that I have, whatever time I have, I would say how we have been cooking this khichdi, or how we have been fitting this jigsaw puzzle by marrying or blending the best of all the worlds, so as to speak. We do not forget the tradition of classical search algorithms or classical planning or classical optimal control algorithms, but we are not rooted in tradition as well. We also are able to imbibe or are able to adapt to what the modern or postmodern frameworks are able to give us. So I'll quickly go through these 7 frameworks which we have developed in the Robotics Research Center at IIIT Hyderabad. Time permitting, we have more, but like this is perhaps enough for today. The Crowd Surfer, which combines VLM plus optimal control, O3D Sim, some of which the panelists have also been there. O3D Sim, Krishnamurthy was there, and AdaptBot, Mohan was there. And so Lego Drive, EDMP plus GPD, and DAG-Diff, which we have just submitted for ICRA 2026. Right? So we start with the smart wheelchair, a lot of which have been implemented on these embodiments. So the smart wheelchair project is essentially about deploying wheelchair in real world, in the wild settings. And here we have developed these frameworks. So we have a vision language, or we are able to align language and vision for goal region. We have batch MPC with the cross entropy minimization for trajectory optimization and constraint satisfaction. We have also in the hardcore calibration space, we have calibrated the 3D lidar here with the camera. And as a matter of fact, we have also seemed to have calibrated the 3D lidar with the omnidirectional camera as well. And then we use both classical planning frameworks as well as the generative AI style planning frameworks for the smart wheelchair. As a start, I show this O3D Sim, wherein we make use of these, the vision and language model along with the 3D camera extrinsics to handle open set queries. So for example, if you query for the wheelchair gets highlighted in the 3D map. Or if you query for the mobile robot, the mobile robot gets highlighted. So essentially, the wheelchair is able to convert complex language commands to goal sequence, and is able to understand the presence of these objects, which the vision encoder has not been trained for in the 3D space. And for the it can also parse these kind of complicated instructions. So if you say, I need to put my hardware away first and then store some clothes, so it's able to understand the table as a place for putting this hardware, and then it invokes the classical MPPI planner to navigate to this particular location. So it moves to the table first, and then it then decides to move to the cupboard as a place to store clothes. Of course, we don't have a mobile manipulator. Otherwise, maybe one could have opened the cupboard and maybe put the clothes in as well, right? The the basic idea is going beyond the classical paradigm. We are able to impart the wheelchair with open set navigation abilities, and we are also able to bypass otherwise difficult mechanism for providing goal in region. Suppose otherwise the user needs to understand where the table is, where the cupboard is, and needs to have a lookup table himself to give these kind of commands to the robot or the wheelchair. But now we are able to bypass these otherwise difficult mechanism of providing goal locations to the wheelchair, and we are also able to, the wheelchair is able to understand non-trivial language instructions from humans, and conversion of such instructions to tokens and converting to goals to which the planner can navigate to. Another thing which we have also done on this wheelchair is what we call as the crowd surfer. The architecture of the crowd surfer I'm not showing here, but it is essentially an occupancy map of obstacles, and then the current trajectory of the robot and the trajectory of other agents in the scene, or just the velocity and the direction of motion of other moving agents in the scene. It takes this as an input and outputs a batch of trajectories through a vector quantized variational autoencoder. But the trajectories which it learns directly from the perception input in the so-called end-to-end framework cannot satisfy many of these constraints. So you need to integrate it with a batch optimizer, such as a batch model predictor controller, along with a cross-entropy minimization to ensure satisfaction of this constraints. And of course, we have done it in closed loop, as you could see it here. And of course, it also transfers to other embodiments like the Husky and in outdoor conditions. Of course, this is not such a big deal because the input space is reasonably perception agnostic, because it's an intermediate representation of in the form of an occupancy map. So the contribution of crowd surfer, as I just enumerated, is generative AI as an effective enabler for batch trajectory optimization, and then combination of this with optimal control formulation to enhance performance. It also highlights the inability of these frameworks to actually negotiate hard constraints. Right? Of course, the wheelchair project is also about deployment in the wild. So here, of course, it's a purely classical stack with perception in the form of an occupancy map, and then navigation in form of the model MPPI. But as you can see, the classical framework is still robust. It is able to handle these, in the wild scenario. This is the demo in our R&D showcase, and the user just gives the goal through the touch screen, and the autonomous driving stack is able to take off from there and navigate the wheelchair in these kind of complex scenarios to the goal. Similarly, we have merged the different pieces of the jigsaw in the autonomous driving framework or in the autonomous driving in our self-driving car, where we use a sparse landmark for map generation. And the car is also able to handle the open set queries, a paper which we published essentially with Krishnamurti being the main protagonist, where the car is able to handle open set queries like football field, right? And we are able to navigate to the football field or the roundabout. And then we use a differentiable planner coupled to VLM for ensuring constraint satisfaction. Of course, this has not been implemented on the car, but the sparse localization, combining the postmodern vision encoders along with classical Monte Carlo methods for global relocalization. So essentially, the sparse lock is a combination of foundational models with classical state estimation paradigms, which provides for a dramatic reduction in map size from 4 million points to 4,000 points. So essentially, going through this, wherein we use Llama 3.2 as the language, and to pass the language instruction, and combination of grounded Dino and SAM for identifying landmarks such as poles and buildings and cars and other kinds of uncommon landmarks becomes the representation or the map. And then, therefore, we are able to convert a dense 3D map built by Loam to a sparse map of landmark centroids. And then we are able to relocalize in this map and navigate the vehicle in this map. So in another thing which we have also done is the Lego drive, which is wherein we use a VLM model to learn a goal region, but then the goal region is learned in a way the planner is able to consume the goal. Often we had seen in the one of the problems in the classical era was the perception stack was agnostic to what the planner is going to do. But in this particular case, the planner is part of the pipeline, so as to speak. So, for example, if you have a thing like park near the bus stop, so we have the clip and vision encoder and the clip text encoder, along with the ASSP decoder, which is going to give you some predicted masks to which the planner is computing the trajectory. But the planning trajectory is self-supervised, is coupled to a planning loss, which includes smoothness loss and hard constraints like collision avoidance. And this is back propagated through the differentiable planner to the decoder, and the decoder is able to improve its goal region such that the planner is able to consume the goal. So the initial goal here, parked behind the bike on the front right, shown in green, was a goal that was initially output by the decoder, and that has been optimized by the planner, the differentiable planner, to the red goal, to which the the car can execute in this car simulator. The green goal, which was initially output by the decoder, was in a constrained space in the presence of the two-wheeler, to which the self-driving vehicle cannot navigate. But then this is now possible through the differentiable QP that propagates the gradients to the perception model and the planner-aware perception stack, leading to better coupling between the perception and the planning stack. So from the autonomous driving or the space of mobility, we have also moved to the space of manipulation, wherein once again we show how we are able to mix various pieces of the jigsaw puzzle to achieve manipulation tasks. So one of the initial things which we tried was this EDMP, which we call as the ensemble of cost-guided diffusion for motion planning, where we have the denoising network, which samples or which learns to denoise in the space of joint trajectories. But then we saw that this just using this diffusion to denoise trajectories was not going to be enough because there were a lot of collisions. And we had to do this inference time guidance over an ensemble of cost functions such that the collision avoidance constraint is being resolved. And once again, here the inference time optimization, which is a gradient planning framework, has its roots in classical planning. As a matter of fact, we use the CHOMP planner style gradient propagation to shift the distribution of the denoising network to go conditional distributions which are essentially collision-free. So basically, what we are trying to say is that the motion planning problem can be seen or was seen in two different ways. So one was the optimization problem, and the other one is the learning-based problem. Right. So the learning-based problem is finds it difficult to satisfy the hard constraints, whereas the optimizer needs to be tuned every time we move to a new input space. So you need to retune the okay. So I think Snehash's call is that. So these are various ways we have combined, the various pieces of the jigsaw to achieve, complex tasks such as this, where we denoise to the parametric space of Bernstein polynomials and do inference time optimization in terms of, to solve the collision constraints. And this is a recent paradigm where we use the inference time guidance to generate graphs which are both force closure stable as well as avoiding collisions. I wouldn't, take more of the time. So the conclusion is, as we saw from various frameworks which we have developed, I think the conclusion, at least we have at RRC, is say there is no single shoe fits all problem. Say there is no, we cannot say that I can have one VLA which is going to solve all these kind of problems. So we need to have, we need to solve this puzzle in a way. We need to kind of design our framework by taking pieces of this jigsaw across various eras. So we need to sample across the eras, so as to speak, to solve the particular problem posed to us. And I think this is the take-home message we have at this particular point of time. And I would stop my talk here and also stop sharing the screen. I think
Yeah, Madhav sir, just a small question, if you can answer in just few words.
Yeah.
That is, how far are we from general purpose, robust household robots? That is, when can we see them out in our own homes? Can we have
this is perhaps the question you should put to the big guys. It was slightly difficult for me to hazard a guess. Maybe this could because I'm not in the industry which has access to, I don't know, several GPUs, and they can do this. There's this learning, the VLA, or they can combine VLA along with some kind of post optimization refinement to solve the problem. But I think it's tough for me to say. But I would, if you want me to hazard a guess, I think we are still not there. And if you see also, I mean, like even in autonomous driving, which was the real buzzword, or which was what like a lot of people were doing 10 years back, 15 years back. But I think there too there are still problems remaining to be solved, even for these Waymo guys and Wave guys. So I think maybe this could be also something which you could post it to the panel, and wherein, yeah, I think. But I would say like the indoor space is more rich than the autonomous driving space. It has a lot more challenges and a lot more embodiments. So, for example, we are now trying to fine-tune Pi0, which is trained on 7DoF space, to 6DoF manipulator, and we have not. We would know by end of this week or next week whether we are able to succeed, right? But then there is a lot more to it than can it handle all kinds of objects? Can it do collision avoidance? Can it, it's. I think I don't see it happen in the next couple of years at least. And yeah, so yeah.
Okay. Yeah, thank you, Madhav sir, and for your thought-provoking insights. I think everybody will take away something. So let's now move on to our panel discussion on the future of physical AI. So we have an exceptional group of panelists with diverse background from academia, defense, industry, and startup. Our first panelist is Professor Mohan Sridharan, Robot Systems Chair Professor at University of Edinburgh, UK. He did his PhD from the University of Texas at Austin. Our next panelist is Mr. Alok Mukherjee, former DRDO Scientist G and current president of the Robotic Society, India. He also runs a startup, I4 Marine Technologies, involving underwater vehicles. Next, we have Dr. Krishnamurthy J, research scientist at Meta and incoming assistant professor at Johns Hopkins University. He did his postdoc at MIT CSAIL and PhD from University de Montreal and Mila. Representing TCS Research, we have principal scientist Dr. Ranjan Dasgupta, who holds a PhD from IIT Delhi. And finally, we have Ms. Bipasha Sen, CEO of Tangible Robots, ex-MIT, representing the startup perspective. So to begin the discussion, I have a common question to all the panelists, and I will come one by one. First question is that, how do you yourself define physical AI? So first, Mohan sir.
Ashish, can you hear me?
Yes.
Okay. So this is and I think like Madhav was saying, this is a bit strange when somebody asks me to do it, because I think the way people are looking at it, if you look broadly, AI for robots and other physical devices, that would resonate with me. That would mean something that I can understand. But at the same time, this is something that I've seen happening for decades now. So if somebody says physical AI as a new thing, I find it a little difficult to understand what it means. So, but if you look at what it is in current days, right? Maybe the renewed interest is because of what we find in terms of development of these large models, large language models, and other such transformer-based deep networks, and the kind of performance that they are providing in a variety of tasks that is, and along with also considerable computational resources that enable us to maybe explore the kind of problems that were previously not possible. So maybe I will leave it there, right? If I take what the word itself means, to me it means AI in some sense for physical or on physical devices, but I don't think it's necessarily a new thing. I think it's been there for a long time. What has happened now is people are developing new kinds of methods to solve those problems, right? So I'll stop there. Maybe it will be, I don't know if it's the same thing that others think, or maybe it's an outlier description. We'll wait and see.
So I will over to Alok sir.
Yeah, I mean, my take is from the other side, from the robotic side. So I say that, I mean, I would like to say that physical AI is amalgamation of another technology into robotics. Robotics has been there for a long time. It is inherently multidisciplinary, probably having all the branches of science and engineering coming into it. So when you put AI into this, that's when you give it intelligence and you go to the next level of automation. So I would say physical AI that's what it is from my perspective.
Okay. KM? Krishna?
Yeah, I would I'm actually very aligned with Mohan on this one. Like, I don't think it's possible to have a very broad definition for something like physical AI. It's one of those things like you'll know it when you see it. So it's hard to define, but yeah, maybe an open AI-ish definition of like when you have a fraction of meaningfully, like economically productive tasks being solved by these systems, you can say we've gotten like a fraction of the way there. Like, yeah, I know some companies have these definitions of like revenue margins. Like we will have achieved AGI if we are able to use our AI systems to achieve X million in profit per year. So yeah, that's a more practical way to look at it, but very hard to define.
So over to Ranjan.
Yes, Nevashish. See, we are working on artificial intelligence for a long time as the community of computer scientists as well as the robotist also. And nowadays we are moving from, prediction to generation technology, right? But they are all limited to the digital world. Whether you say it is a language input, language output, whether you say it is an image input, image output, they're all limited to the digital world. And we used to coin as, used to call it agentic AI or AI agent, or maybe group of AI agent from the agentic AIs. But in terms of physical AI, when we talk, we have to come out from the digital world, right? That is the first challenge, because the system is going to interact with the environment. It has to intervene with the environment. And how can you develop your intelligence while interacting with the environment? That actually leads you the development of physical AI. Now, it should not only intelligence, it should talk about learning, it should talk about reasoning, it should talk about both learning and reasoning, and it should also talk about how it can improve the planning, because it has to face different type of uncertainties, and it has to behave like a human. That was the expectation is, maybe after a few years down the line, that how it can react like a behavior in an uncertain environment. So last my word is that it is some sort of brain which is going to be developed for a robot like systems, or maybe for the autonomous systems, right, which is embodied, and the entire robotic agent will be embedded in the environment to respond in uncertainties. That's what physical AI is. Thank you.
So now Bipasha.
Yeah, great definitions. I think very similar to Ranchan. AI existed in the digital world, in the cloud, on our websites, on our portals, but anything that can sense and perceive the real world with different kind of sensors, and also like interact and manipulate the state of the physical world. I think that would be physical AI that exists and interacts with the physical environment around us.
Okay, so Mohan sir. So now the second round of questions to all the panelists. So this is a bit type of question everybody is waiting for. Will physical AI create or eliminate jobs? Mohan sir.
Okay.
Everybody
I
has to
think
answer. Yeah.
No, I know. I'm not going to. I can always share my views on these kind of questions. Okay, so it's a slightly okay. Like with any technology, right? This is a sort of standard template answer first. Then I'll expand. Is that with any technology there are opportunities both to create and to lose jobs, right? But with AI, because of the rapid development, the rapid pace at which it develops, there's just a note of caution I'll inject and say that it depends on how we develop and use it, right? It depends on how we develop and use it. And if I want to expand that one more layer, I would say that if it's developed with, say I would say scientific rigor, right? We are careful in how we develop it and how we use it. We are transparent. We respect privacy, right? We respect safety constraints. And we also engage all possible communities that are going to be impacted by it, both in its development and its use. Not, it shouldn't be the case that we say, here we have created the system, now we will make it safe, right? What I mean is from the development stage, we design and development stage, if we respect all these principles and use them in the design of AI methods and in the use of AI methods with proper regulatory safeguards, then it has considerable potential to significantly enhance our productivity and significantly enhance our quality of life. But in parallel, this will only happen if we say, okay, we're going to remove all the repetitive or mundane jobs. So there are a lot of people engaged in them. So in parallel, it is important that we provide considerable support and provide considerable resources, both in the education and training, right, in the skilling of people, giving them proper skills, and only then can we truly achieve the positive outlook. Like, as an academic, I would like to post this positive outlook, but I will also put in a note of caution that we are already seeing many instances of AI being used with or without robots to considerable damage, right? So we have to work against it. Thank you.
Hello, sir.
Yeah, my take is again a little different. That probably physical AI will take the robots to man. I mean, to where man has not been before. More like the Star Trek movie. So the AI, once it is injected or put into these robots, it will see a complete transformation of the automation and machines which come up, and this will breed a new class of or new type of engineers, technicians, scientists, and so forth. I don't think it will eliminate jobs. It will only transform from one domain to other. That's what my take is on that.
Okay, Kim.
Yeah, I think the answers from both Mohan and Alok have covered some of the topics that I've been meaning to talk about, but I'll then try to talk about disjoint. So one of the things when we talk about physical AI and like the risk of it eliminating jobs is what kind of jobs are we talking about? Like, are these jobs that no one wants to do but somebody has to do? Or are these jobs that some people just do because that's the only source of their livelihood? And the question is also like, as society, would we be better off if these jobs were automated? And what's the also like, will those jobs ever be automated, and what's the time frame for that? So you can think of some jobs such as industrial assembly, etc., being more automatable than, say, yeah, things like, no, just cleaning up a house. I know we have robot vacuums, but I'm talking about reorganizing everything so that it looks pretty for whenever you're back from work. So I think the timelines on that, just given how hard these problems are, we have a good runway to take on these problems. Like, if we think we have the next 5, 10, 20 years, what's the outlook? How do we plan? And it's right about now that these conversations start, like, they need to start happening so that when the technology actually arrives, we are in a state to handle it better. And so, yeah, my mind goes back to all of these phone booths which we had. Like, I think I witnessed the very rapid decline of phone booths when as a business model. So there will inevitably be like some kinds of jobs or businesses that go down faster than the others, but there needs to be like a very tight loop between the scientists and researchers developing the tech to like the policymakers and government, so that we have a good sense of what is going to be solved and how long and to what extent, and that's what determines like how do we plan for eventually. So it's not like jobs being eliminated. Think of it more like the flavor of a job is going to change. Just like a lot of people these days use coding assistants, and that has changed the way tech employees conduct their jobs, and to an extent, like how they're interviewed for new tech roles and so on. So that in the digital AI space, changes are going to be much faster than in the physical AI space. So we also have the opportunity to start learning from, like, we have lessons learned from digital AI deployment, and let's make sure that doesn't happen when we deploy physical AI agents.
Okay, Ranjan.
Yeah, it's very hard to answer this question, but I would like to play a agnostic role here. Neither I want to prove this hypothesis nor I want to disprove this hypothesis, right? So this is my first contradiction here. The question is why physical AI? Because we are all actually chasing the famous dialogue from Moravec's paradox. The task which is very easy for human, it's extremely difficult for a robot to do. So every community is actually reaching to that word. How a robot can be more dexterous, more efficient, and it can perform like a human people. That's the thing. But the question here lies, will it really replace the human? There are a lot of reports has already been published that, okay, we have make a transition from automated to autonomous systems. If you go back to Industry 4.0, we already achieved industry in autonomous robotic systems, right? But the thing today is like that even we have automated 80% of the work, but still we need 20% of the work which is human driven. And surprisingly, that 20% of the work actually takes more than 80% human effort. So it's just like 80-20 rule in a software paradigm, correct? So that means 20% work still remaining, which you cannot autonomous within the state-of-the-art technology, right? Whether it is an LLM, whether it is a VLM, whether it is a vision action, language action models, it's hard to reach to that place. So I do believe that human have a lot of opportunity still in the autonomous place, right? The second thing is that the more the technology will grow, what Madhav sir is actually talking about, right? Whether it is in terms of navigation, manipulation, right, or grasping, anywhere you take it, right? It is trying to augment the human. It's trying to help the human, correct? It's not going to replace the human. So if I say that earlier, when those capabilities or intelligence was not there in an automated system, maybe it takes, X amount of time to reach the goal, correct? Just by the human, if you want to do. But when a robot comes into the picture and it is going to cooperate with the human, probably we will be able to do it by X by 2 time frame. So just like 30-40% time reduction can be achieved, whether it is in warehouse, whether it is a last mile delivery, whether it is a manufacturing assembly line, anywhere. So that matters. So it indicates that no, the technology is not going to replace humans at any point of time. But of course, the organization level, we have to think that there are a lot of repetitive jobs has to be done by the robots, which will actually, ease out human problems. And we have to think about how we can upskill and reskill also humans, what you are doing for a continuously for last 10-15 years. But now there is a change to shift your skill, to improve your skill, so that you can do more critical thinking, more decision-making jobs, right? Which even today, it's very difficult for the robot. Otherwise, physical AI doesn't have any meaning. So this is my actually takeaway from your questions. Thank you.
Okay, Bipasha, your take.
I can provide like a startup perspective. From our lens, it'll substantiate and augment jobs much before it'll replace anything, because like everybody else said, we're still far from the idea of truly autonomous robots. But outside of that, there are still like many jobs that are just not suitable for humans to do. Anywhere where it's dangerous, or anywhere it's like one of the startups I know, they're trying to like clean ship hulls, and they're trying to clean the ship hulls when the ship is in motion. So some of the things that the robots are trying to do, the humans just either can't do it, or it's extremely dangerous, or it's like not appropriate for the humans to do it. So many tasks that the robots will try to automate is places where it's already hard to find humans to do that particular job, and there is more labor shortage than we can imagine in every single sector. So initially, I would say like the robots will augment and try and fill the roles that have no other options, and make sure that they run well. But in the future, it will also create jobs because, like every technology, any kind of innovation leads to jobs that we haven't seen before. And at the same time, it'll reduce the amount of like jobs that I think a lot of people think humans shouldn't be doing anyway. Like they should just be like focusing on something more creative and so on and so forth. So that will open up, and I think it is much less scary than how it is portrayed to be, and it will have much more positive impact than any level of negative impact.
Yeah, thanks, Vipasha. So I will just request the audience in the live YouTube and to post questions, and we'll pick some of them. At the end, we will ask the panelists to answer. Now we move to the one-to-one questions. So the first question is to Professor Mohan. So will large foundation models dominate physical AI, or is there a chance of small models also?
Okay. Just a quick voice check. Can you hear me? Okay.
Yes, yes.
Okay. So first, I think I'm going to, so I'm an academic, right? So I want to be careful in what these terms mean before I answer that. Right? If by small models you mean smaller language models, no, I would like to expand that a bit, unless somebody protests. And I would say that I will consider smaller models for just what the term means, right? Models that are simpler, right? Not just smaller language models, right? And why am I doing that? Because I think what I would actually advocate is that we need to use what shall we say, an integration or combination of different representations and processing mechanisms. With the current push, partly hype, partly good performance in some selected domains, we are going to the time where we are saying that these deep networks are the answer to all the problems. Well, historically, and whether you look at it from an economic viewpoint or academic research viewpoint, AI has demonstrated much more success in the work that has happened before than what is happening now. It might be a little difficult to believe, but that's what it is, right? And so what I'm saying is if you look at these choices we make when we say what representation we use and what processing mechanisms we use, that's like developing a vocabulary and developing rules in which you can change the vocabulary. And that then determines how you can communicate. In the same way, if you want to realize the goals of having AI work on robots and display behavior of the kind that we really value in humans, the adaptability, the plasticity, the ability to learn and work in new situations, then we have to go back to those principles that were well known for the early pioneers of AI. But I feel old when saying this now to even to my students in my classroom that these are increasingly forgotten and then they are rediscovered. So I'm going to answer your question by saying that what needs to happen is to think of the current development with deep networks and this transformer-based models as one of many different tools. And I will go beyond what Madhav was saying. We don't need to just combine them. We fundamentally need to rethink what we can learn from the different representational choices these different methods are making and then develop new architectures. And I think that is what will get us closer. Whether we will get to these goals of physical AI, I do not know, because this is a hard problem and we are far, far away from it. Current robots do not display anywhere near the capabilities that we want to achieve, right? So, but assuming optimistically that we want to get there, then the key step that I'm going to advocate for is to move beyond this craze or hype around these single collection of methods or models and look to fundamental principles that have existed in AI for a long time and develop new architectures, new frameworks that build on those principles. I'll stop here.
Now, Alok sir, so what government initiatives do you foresee can make a country the leader in physical AI?
Okay, that's a big question. But nationally, I can tell you, I mean, what my experience is that if you're talking of physical AI, where we are lacking for us is the physical part. That is the robotics part, the hardware part. We may be strong in digital AI, but as far as the physical AI, where you have the robots which have to do the action, whether you're talking of grasping or manipulation or autonomous cars, where you need to have localization and perception and so forth. Where are the machines? So The machines, making those machines is where we lack on, if you're asking what. Therefore, I feel if government has to give an initiative, if this whole thing will work, if you have the physical robots and if you have the algorithms or the digital AI, they both has to work together. So I feel if you're asking that what should we encourage is uh, the bring about innovation in the physical sense, in robots, in automation systems. And yes, government is doing a lot, promoting a lot of innovations from various ministries. So many of you might be aware of DST, MIT, and so forth. So many ministries are encouraging the innovation by giving grants. But as far as giving grants, because I'm in some of the review committees and I can tell from that side that you should, the grant should be given to the startups and not ask about, I want so much equity and I want this, I'll give you on loan and I will not give you. Grant is grant. You should give it as a grant in aid. And then worldwide, the average of product success is 2 to 4 out of 10. You can't expect that if I give you X amount and that will give you a success. So you would probably get X by 10. So going by that, so government should realize that. And if you're asking me government initiative, you give this initiative, encourage innovation, and don't expect that everything that you're giving grants for is going to succeed. Because succeeding in a product, making a product is something completely different. So that's my first point. The second point is what government can do is in the syllabus. What I see lacking in the graduation or graduate courses, postgraduate courses, MTechs, very, very rarely we talk about product design. If you don't talk of product design, an engineer, when in the budding years, he doesn't know what is a product and how does he design a product as such. So government should bring about a syllabus change where product design, in my opinion, should be given a top priority. Then and only then you will find the new engineers will be tuned towards going to the physical world and making products or the engineering part, and not the easy way out to go and sit on a computer and start writing the algorithm. Pardon me saying that, but that's what it is. When you go to the ground, the problem is very much different. So that's what I wanted to say about what government initiative should be, to give grants and to give it to the correct people. And my last point is, these entrepreneurs who are going to go and carry out the innovations, they should be encouraged to attend workshops by people who have already achieved. What I mean achieved, who have made products in the industry or in academia or in research organizations. There are people who make products and who have succeeded in making products and getting into the market. Ask them to tell the new budding engineers by government initiative that what it is to make a product. And unless that comes up, unless the physical world improves, you're not going to have, you can't be a world leader in physical AI. So that's my take on it. Yeah, thanks.
So to KM, so the question is that, are simulations enough, the usual sim to real path, or do we need large-scale physical test beds to test our algorithms?
So I'll rephrase that question as, like, if you're asking are simulations necessary, I would say absolutely. Like across most of the problems that robotics are working on, I'll elaborate in a bit. But if the question is, are simulations sufficient? Then probably not, depending on the core observation for me has been the more you require interaction with the physical world, the less and less simulations are worthwhile. But you can't skip simulations even in those high stakes scenarios, just because there's a lot of things you can test out in simulation that you cannot simply in the real world. So think of most of the success we've had as a community. One of the things that we've seen success, especially over the last 3 or 4 years, is in locomotion. And locomotion is a big simulation success story. So most of the methods we see for locomotion today that are deployed, like if you were seeing all of the unitary demos to like a ton of humanoid companies around, they're all like predominantly training in simulation. And it works in that case because the interaction with the real world is just basically contact forces on your foot. They are very sparse. So as long as you can model that variation in sim, and create like a ton of parallel sim instances and train your policies, you can get good locomotion policies. And we've also seen like, to an extent, navigation successes in sim, although partly informed by like, there's a loop between the real world and the sim, and there's this loop continuously keeps updating. And when it comes to manipulation, we get to see like a sim success story for just dexterous manipulation of everyday objects of various sizes, and like there's this very few success stories. The ones that come to mind are the Rubik's Cube demo by OpenAI and other in-hand reorientation demos, which require like tens of thousands, if not millions, of examples, which just means like general purpose manipulation is much harder. The key difference here is also like the amount of interaction required with the real world when you think about locomotion versus manipulation. Now you can start thinking about what it means to do like bimanual manipulation, use two hands, and you want to manipulate soft and hard objects of different weights. Then you need to have some kind of force torque sensing, maybe even tactile perception, and that just becomes harder. So the sim problem will become as challenging as like deploying in the real world. So I think at this point, especially the industry is settled onto, let's just collect teleop demonstrations, and then we can get robots to do some subtasks really quickly. And I think the challenge now is identifying what subtasks are the most economically viable. And if we increase the extent of interaction, like think about deploying robots in in the presence of humans, then there's a lot of aspects you can't faithfully simulate. And for that, you will need to deploy in the real world. Yeah, one concrete example I can give you is I have like two tiny bimanual manipulators in my office desk, and I have 4 cats in my house. The cats are not allowed in the office. I would, just as much as I would not like the cats near the robot, I would also not like the robots near the cats for various reasons. Just because we have no idea of, well, humans is one step, and then other sort of, a lot of households have pets and other environmental factors to consider. So some of them you can't faithfully simulate, and you will have to bite the bullet in deploying the real world. So my just this summary is the extent of interaction which is where determines the efficacy of simulation as a test bed.
Okay, thank you. So now next question is for Ranjan. So will physical AI be domain specific, like say manufacturing, healthcare, retail, or will it be a time will come when we can have general purpose robots?
Yeah. First of all, am I audible? Once again.
Yes, audible.
Okay. Thanks for your confirmation. It's a long answer actually. It's very difficult to say in very brief, because when the era of robotics starts, people are looking for specialists even today, right? Whether if you go to any automotive company, or if you go to manufacturing company, you will see that robot is continuously doing repetitive jobs, right? And that is it's meant for. Correct. And more it do the repetitive jobs, it is expecting that it will go on improving its efficiency, lead time, delivery time, as the technology improves. So that means people are looking for specialists. But the flip side is, the requirement is changing dynamically. And most of the time, if you see whether it is a manufacturing side or assembly line problems or automotive problems, right, or warehouse problems, whatever, you see, actually the requirement changing in low volume, but there is a high mix-up. So we used to call low volume or high mix requirements. So that means if there is an automated system, it may be a machine or it may be robots, the demand is it should know how to adapt with the changing requirement. That's the thing. Now, moment I say that it should know how to adapt with respect to the changing requirement, I cannot say it should behave like a specialist, right? Because adaptability will come definitely what intelligence is has, right? Whether it is a traditional robotic intelligence in symbolic form, or today what we are discussing about physical AI, right? What I used to think it just like a brain, right? Some sort of. That means we are moving from automated system to autonomous system to autonomic system, which actually can take its own decision, which should be resilient, and which can take up the challenges if the environment changes or uncertainty arrives. So now, moving to your questions, so the demand is no longer specialist. The demand is also moving towards generalist. But you know, the irony side is that the moment the robot will become or try to become generalist, again he will say, okay, how efficient it is, right? How fast it can do the job. So that means there is a chicken and egg problem. So you try to make it generalist, but again, the end expectation is that it should overcome the human efficiency so that it can yield a better result at the end of the day. So actually, the requirement boils down to, again, a boring specialist. So it's very difficult in that sense. But whatever the technology exists today, I cannot say that it is domain agnostic, right? The robot which is very expert in assembly line, it cannot do domestic jobs or house cleaning jobs, housekeeping jobs. The robots which are deployed in hospitals for caregivers, right? Or for the medtech companies, where it can be used as a assistant, it cannot do the jobs which is being carried out by the robots in a warehouse or in a complete fulfillment centers, right? So I cannot say that it is domain agnostic. Rather, the approach should be in something way that it should be trained for a special environment, for a particular domain, and then you inculcate the new technology, what Mohan is also talking about, or fuse the older technology along with the new one, so that it goes on adapting from the current domain to the newer domain. That's what the progression should be. But the challenge is, other side is, if we go to the traditional digital AI systems, right, you need a humongous data, right? And you need a humongous infrastructure to get trained on them. But will it be applicable for developing physical AI, and that too in an agnostic manner, so that the robot can work across different domains? That's an open challenge, right? Because first of all, the scarcity of the data, we ain't get the internet scale data which is available. Even if you crowdsource the data from the labs, from the universities, or even partly from the industries, right? It's very difficult for a robot to get trained the way a simple digital assistant or in a agentic or AI agents is being trained. That's the first potential problem, right? And the second thing also, as I said earlier, that though there is a transformation happenings, but we have to get out from that uncanny valley like feelings, right? Because we are moving to the era of humanoid, and it is very difficult for a human to accept a humanoid, right? So that means it is something like appearance like you, but it is doing better job than you, right? It is doing faster than job like you. So we have to get out from the uncanny valley like perception. We have to accept the technology. We have to accept them. Even in the near future, even they appear as a cyborg, we have to accept and see how they can cooperate and coexist with us. That gives the real benefit, right? Whether it is in the same domain or whether it is a different domain, that depends upon how intelligent it is, how adaptive it is, how reasoning capability it has, how quickly learn it has, how actually it is more dependent on itself rather than demonstration created by the human or teaching from the human. But the question is that how we can transform the new task each and every day and upskill and reskill ourselves so that robot and human can coexist and they can move from one domain to another, what Industry 5.0 is looking for. So that's all my takeaway from your question. Thank you.
Thanks, Ranjan. So now time for Bipasha. So what do you see the hardest unsolved engineering problem in this particular space?
Unsolved engineering problem. I think there are many unsolved problems still.
Which one do you think is the hardest?
So at every level, I think there are different problems that are very challenging. Like, for example, the hardware itself. If you really think about it, not even though you have so many different options available, none of the hardware can actually do some of the things that humans can do very easily. And that's a huge engineering problem because when it comes to hardware, there is very limited amount of like novel mechanisms or novel innovations that people are trying to do it, but it's more about like how can you put them together to make sure that the hardware can perform at the level that you want it to perform. Like, can it have the right amount of payload? Can it have the right amount of compliance, force sensing, making sure that the entire bill of material, which is the cost of the robot, is under control. Because if a robot is $100,000 or $200,000 to make, then it's not economically viable. So building the hardware, it's still an unsolved. It is solved in a level that you can see the robots doing backflips, but at the same time, there are not too many robots that can actually go and manipulate at the level that even the most basic task a human can. I mean, coming to hands, there are no options for hands. Like, it seems like there is a lot of progress, but in reality, you don't have a single hand that is capable enough to do more than just like grabbing or pulling or opening cabinets or drawers. Like most of the hands that are stable enough for any kind of commercial use, they are 6 degrees of freedom. Anything more than that, it's absolutely unviable for any kind of commercial use. They're good for research because you can do research. You don't need it to be like so robust in the real world, but it's not good enough to be to even act like as a starting point for even the simplest applications. So the hardware itself, I would say that it is good enough for very, very basic tasks like pick and place, but anything more complex than that, which is the goal with any form of like versatile general purpose or multi-purpose robots, they are still like we haven't seen any such robot really deployed. Forget about scale, even not at scale in the real world doing real tasks. All of the videos that you see for BMW with vigor or like agility, they are very cherry picked and they're not really in production. So none of these robots are actually deployed or making any impact in the real world. So hardware, I think, is the biggest still like unsolved. There's still a lot to do for it to become anywhere close to the general purpose that we imagine. It is somewhat, I would say, ready for multi-purpose, but not as much as like any complex manipulation that we wanted to do. Outside of that, from the perspective of AI, I think when it comes to robotics, it's not a single model that will solve the entire thing end to end, but it's usually like many different pieces put together as an engineering system that will make the solution work. So things about perception, the low-level motion policy, or I mean, we have like end-to-end models that are supposed to work. But even if you think about how ChatGPT and all of those models work, they are not a single model. That's like an engineering pipeline. So because we have not even reached to that point where you can start putting these things together, I think that's an open problem that needs to get solved. and we are still far from like figuring that aspect out. So I would say like on both the fronts we have started, but we are not there that there are still so many open problems that there is not one singular hard problem to solve. There are like all pretty like open-ended, and you need to like solve them in stages.
So thanks, Vipasha. So now we move on to the audience question. So I have a question from Karthikeyan regarding an open source Git repository for related to physical AI. So can you answer that? So if somebody wants to look up.
My read of the question was geared towards the presentation part, where a lot of papers were being showcased and questions.
Yeah, I know that.
I can speak about the work I was involved in from the talk. So there's the concept fusion work, for which there is an open source repository. And I believe most of the projects presented in the slides have project web pages. So if you just Google the paper titles, you'll land up on project web pages. Some of them might have code as well.
Okay. So the second question is from Shubhasish Das. So it is regarding intelligence beyond screen is true, but what about sustainability? When data gets choked, referring to strong GDPR-like policy, other in the absence of human intelligence, how can an organization handle such situations? So to summarize, the question is about sustainability and how to deal with the GDPR when we are dealing with robots. To be more specific, the robots will be moving around in indoor environments, right? So there will be some privacy issues that will come. So I will request Mohan, can you take this question? Mohan.
Okay. Yeah. Can you do me a voice check, please?
Yeah.
Can you hear me? Okay.
Yes.
So, I think everybody knows this, but this is data protection regulation, right? That's what GDPR is, just for those who do not know what that is, right? And so I think I'll use this also as an excuse, if I may, to say that this is one reason why one has to take care in the development and use of these kind of AI systems for robots. And I'll also kind of point out, and I hope this will be okay to this audience, that in much of the discussion today, when we have talked about physical AI, we have looked at the these large transformer-based models and other systems. And if we notice, a lot of the problems that we face are then self-created. We say, oh, what will we do for large amounts of data? Then we say, what will we do for large amounts of compute? Why do we need large amounts of compute? Because we've already trusted all our processing and everything to these kinds of large models, right? So I would say that the answer to this question is actually those specific points of sustainability, privacy, and other issues is why the development and use of these kinds of systems should be done with care, and we should not use them as the answer to all kinds of problems that we face in robots. We want to have AI work on robots and robots work in the physical world. And again, I will highlight that this has been happening, the use of AI for robots and robots being used for practical applications. I think even Madhav mentioned in his talk, the having AI work on robots and thereby being able to do SLAM and navigation and control in mines and outdoor areas. This has been going on for decades, right? So the key thing here is we have a nice, useful tool, and if we want it to be sustainable, what we should do is we should use it as a tool for applications where it is useful, as in places where it is well suited. But at the same time, we shouldn't use that as a single tool for all kinds of tasks. If you use it in combination with other cases, in situations where we don't have sufficient data, where we don't have human to do constant supervision, there are mechanisms in AI, and they have existed, again, I feel old reminding people of this, for decades, which are able to provide the kind of capabilities we want, transparency or explainability, right? Doing compositional work, doing providing nice interaction, right? And also being able to deal with fundamental problems in perception, reasoning, navigation, and control. They have existed for some time. So the interesting question or challenge to me, and I will post this as a challenge to people who want to look for new problems, is find ways where you can combine these in meaningful ways and not just as separate components, as a fundamental integration where you jointly look at perception, reasoning, and control problems with the availability of human knowledge and including that in meaningful ways, I think then we address these problems of sustainability and we are able to create systems that are truly useful for us. I'll stop there.
So just one final audience before we wrap up. It is for Mr. Alok. So in the US, this is a YouTube question. In the US, Scout AI is working on AGI for defense robotics. For India, how do you foresee that India should build its own AGI or leverage the existing models of the West?
See, so I can tell you what I know. I was not working in that domain, but you see, if you're talking of defense applications, this has been going on, like my fellow panelists told, for a few decades. When the Tomahawk missile came up, which is a surface-to-air missile, or any, in fact, any cruise missile, which hugs the earth and goes, it uses different techniques like terrain contour matching for terminal guidance at the end, and how do you home onto the target. This has been going on for not today. I'm talking about Tomahawk, which was I think somewhere around 90s they started, and coming closer home, we have the LRSAM, or long range surface to air missile, which is being developed by DRDO with Israel. We have the BrahMos, which is with Russia, which is being used. All of this has got AI in its terminal guidance, and it's not today. It's been from a long time, and these help the missile home onto the target precisely without being dependent on the GPS. So that's the whole aim, where you have a thermal imager, you have a navigation system. Now we have our own Navic system as such, and you have a radar, and all three merged together. This data and this is merged to finally come up with a terrain model, and the stored terrain model as to where you have to go and hit is already fed into the missile. So it's a fire and forget. You've already programmed it and left it. So that's all the work that you have to do in the background. So that's even in our latest operation Sindoor. I mean, I'm sure they would have used these kind of technologies. I'm going by the paper reports, nothing about what I'm not in DRDO anymore. But yes, because you did hear in the paper that even ISRO was working overtime. So if you put two and two together, you'll know from why were they and what was their role in the whole. So we have our own models, and we have our own research and implementation onto these missiles. You can't depend on something bought out as such. Yeah.
Okay. So it's time, like we have covered academia, policy, enterprise, and startups in our panel. I will just ask all the panelists to tell only one or two words. What excites you most about the future of physical AI? So, Mohan sir, what excites you most about the future of physical AI? One or two words.
I hope you will at least give me a couple of sentences and not just one or two words.
Maybe one sentence.
Okay,
Finish.
What excites me most about the future of physical AI is that it has renewed attention on problems faced by physical systems that sense and interact with the physical world. And it has provided us probably I would say, an immense opportunity to finally create systems that will build on certain key fundamental principles that will enable us to provide the kind of capabilities we need instead of just depending on one software or one tool that is currently being hyped much more than its existing capabilities.
Okay.
I'll stop there.
Okay. Alok sir, it's few words, one or two words.
One or two words on what excites me is that probably the enthusiasm towards physical AI, and that has given rise to a lot of impetus by the government to fund. And because I'm from the startup now, so I can tell from there. So the startups have been encouraged to come up with newer hardware where this physical AI can be implemented and indigenously. Yeah, thanks.
Again,
Well, 2 words, intellectual curiosity. Longer explanation is like, yeah, who is not excited about just seeing robots work? Well, I am, and it's for me personally exciting because you can now make a career out of it. Yeah, you can work in this full time, and the community seems to be excited. So yeah, win-win.
Ranjan?
Yeah. Am I audible?
Yes.
Ashish? Yeah. See, I'm very much optimistic in the field of robotics and physical AI. So, what I do believe is we should move from automated to autonomous, and finally we'll end up with autonomic robots, right?
Okay.
Which actually overcome the Moravic's paradox. That's what I can say. And it is only possible if we can bring, computational neuroscience also into the picture, so that we can land up with some sort of robotic nervous systems which can independently work like us. Thank you.
Bipasha?
I'll talk about robotics, and I very strongly believe that this is the next internet moment, the next trillion-dollar industry, and this will change the world.
This will change the world. Now, Madhav sir, a few words. What excites you about physical AI? And we are towards the end of it. Your audio is still muted.
Yeah, I expect to be questioned. I think, yeah, I mean, see, like there have been several problems which are kind of very difficult, which I think has a lot of immense value. Like, for example, if you want to, I haven't seen a robot which can, if you look at the way, quickly, I mean, there are many problems, like, for example, climbing coconut trees and dropping coconuts. To do mopping in the Indian style, like it's not the Roomba kind of mop, but if you look at the way, you have a pole and then you apply pressure and then you mop. I haven't, that mopping is generally more efficient than the Roomba style mopping. There are sewage, cleaning, clogging. There are numerous problems in the space of perception and action, which we can solve for general betterment. I think. Yeah,
So thanks a lot to all the panelists. So we have come to the end of this session. And to summarize, the days of Star Wars and iRobot seem to be very near, and we are all looking forward to it. So, and we hope that we will all together will be part of this new journey of this physical AI, the next breakthrough in AI that we call. So thanks all. Goodbye for now. Signing off.
Sorry, Snehashish, before you leave, a special thanks to everybody who organized this, right? Let's not forget that, to ACM India, to TCS, whoever participated in organizing this.
Yes.
And in your vision for Star Wars and iRobot, I hope you don't want all the wars to happen too. I hope it's a safe, productive environment and not the environment you are. It might bring different visual views to people. I'll stop here. Thank you.
Okay. So,
thanks a lot, sir. Hashish.